Welcome back, Physical Science 20. This is the HT1 review. So in this unit, we did HT 1.1 warmth and coldness, 1.2 heat, 1.3 heat capacity, and 1.4 states of matter and changes in state. So just like other exams, there'll be 10 multiple choice questions worth 10 marks, and the short answer question section will have 6 questions worth 32 marks, so a grand total of 42. To give you an idea of what those 6 questions will be, so number 1, I'll have some heat terms that I'll get you to define. And of course, those are right from HT 1.1. So that's worth 3 marks. So there's likely going to be 3 terms there. Number 2, there'll be some fill in the blanks using heat terms. The terms I'll be picking will come from HT 1.2. And then question number 3, some real life applications of heat. So kind of real life questions. Ones that you've likely seen before are very similar, from sections 1.1 and 1.2. Okay, and then after that, getting into 1.3 and 1.4, we have some of the calculations, so quantity of heat calculations. So when you have a solid or liquid or gas, you'll have its specific heat capacity. The reference sheet you'll get on the test will look something like this, so it has all the charts that you need, plus all the equations that you need. So the specific heat capacities, or the C values, you pull directly from here, whether it's water or aluminum or ice. So all of these represents joules per kilogram degree C. So to make 1 kilogram move 1 degree C, this is how much heat is involved. And of course, this relationship here just basically looks at, okay, what if you don't have 1 kilogram? What if you have more or less? And what if it isn't just 1 degree C change? So that's where this comes into play, and you can figure out Q or C, etc. Number 5, thermal energy and heat. So the last part of 1.3. So this is kind of the first part of 1.3. This was the last part of 1.3, looking at thermal energy exchange. So when you heat up a metal and drop it in water, figure out various things such as the identity of the metal, looking up the C value or mass of water, etc. So that uses this relationship here, in which you have a Q equals MC delta T and MC delta T for each. You can look back in 1.3 and see how you did those at the very end. And then lastly, thermal energy calculations using heating and cooling curves. So you should be able to draw a sketch of heating or cooling curves, look at the 5 basic parts of a heating or cooling curve, such as the 3 phases, solid, liquid, gas, and the transition. So recall that this equation here that we just used is used when you have a solid, or you have a liquid, or you have a gas. But when there's a transition part, that's where you look at if it's melting or freezing. You're using the latent heat of fusion. And of course, there's these charts here, latent heat of fusion. And if we're going from liquid to gas or gas to liquid, latent heat of vaporization. And of course, that's using this same type of formula here. And the L values, the latent heat, of course, are joules per kilogram. So if you have some different amount, not 1 kg, but some different amount, that's where we use this, of course. Okay, so you will have this on the exam. So you'll have this. I even outline mass in kgs, etc. You need to have for all of these equations the latent heat of fusion or vaporization, etc. So I'll have this. I'll likely post this sheet just on Google Classroom as well, just so you can take it and have it. And it'll also be attached to the test. All right, so again, if you have any questions, please email me or wait till I'm online, and then you can ask if you have anything that you need to know about. All right, we'll see you again.